I welcome you all. In this video, we will solve a numerical on design of shaft subjected to combined bending moment MB and torsional moment MT. Okay. Now let us read a problem. Design a shaft to transmit power from electric motor to a machine through a pulley by means of a belt drive. Okay. So power is transmitted from motor to a machine through pulley and belt. The shaft is supported between two bearings 1000 mm apart. Okay, so length of shaft is 1000 mm and the distance between two bearings is 1000 mm. Pulley with belt is located centrally in between the two bearings. So location of pulley along with the belt is at the center of a length of span of shaft. Okay, so that is from one left side bearing it is at 500 mm from left side bearing and 500 mm from right side bearing. Weight of the pulley is 350 Newton. It is a self weight of pulley which can be considered as one of the load in this system. A diameter of pulley is 180 mm. The maximum power transmitted is 2.5 kilowatt at 150 rpm. The angle of lap, which is also called as angle of wrap or angle of contact, it is given 180 degree. The coefficient of friction mu, it is given 0.33. Okay. Remember that we need this angle of lap in calculation. It must be in a radian, so we need to convert this degree to radian later. And then the shaft is made up of steel, so this is very important. Now material is ductile or brittle is first of all we have to see, because whenever the shaft is subjected to combined loading we have to select the theory of failure. Okay, either we have to use the maximum principal stress theory or maximum shear stress theory whenever the shaft is subjected to combined loading. As here the material is steel is given, so that means it is a ductile material and we have to choose a maximum shear stress theory to design the shaft for this case. Okay, the SYT value is given, it is 380 megapascal and factor of safety is given 4. So let us write the given data first. Now let us write the given data. First of all, we have to draw a diagram as we have seen in the previous part, that this shaft carries a pulley and it is carries a pulley at midway between the length of shaft. So we will show some data into this diagram, and remaining data we will write at the below this diagram. Okay. So design a shaft to transmit a power from electric motor to a machine through a pulley by means of a belt drive. Okay, so this system consists of a shaft with pulley and belt. The shaft is supported between two bearings, so we have shown these two bearings 1000 mm apart. We have shown this distance between two bearings, bearing A and bearing B, at 1000 mm apart. Pulley with belt is located centrally, so this is a pulley with belt is located centrally along the length of this shaft. So distance from one bearing and this pulley is 500 mm, and distance between this pulley and another bearing is 500 mm. Then the weight of pulley is 350 Newton. So we can write here load is equal to W. Okay, W, that is self weight of pulley. Okay, so for our understanding we will write here W is equal to self weight of pulley. It is 350 Newton. Okay. Next, the diameter of pulley is 180 mm. So I have shown the side view of this diagram, where I have shown the side view of this pulley, where I can write the diameter of pulley as 180 mm. Okay, so pulley diameter is 180 mm. Next, power transmitted is 2.5 kilowatt. So P in kilowatt we can write as 2.5 kilowatt. Then RPM of shaft is 150. So capital N is equal to 150 RPM. Next, the angle of lap, which is also called as angle of wrap or angle of contact, it is given 180 degree. So theta star is 180 degree. Star is just written here so that you can able to distinguish between angle of twist and angle of lap. Okay, so in this problem anywhere if you find the term theta, it is related to angle of lap. So just for the identification I have made the star, and although we don't require here angle of twist in this problem. Okay, So we required this angle of lap or angle of contact in radian. So as it is given in degree, we have to convert it into radian. So we have to multiply by pi upon 180. So this 180 will get cancelled, and finally we get the angle of lap as pi radian. Okay, so this is the value of theta in a radian that we have to use for further calculation. Then the coefficient of friction is given 0.33 between the pulley and belt, and shaft is made up of steel. So as material is steel is given, so we have to use maximum shear stress theory, and SYT value is given 380 megapascal or 380 Newton per mm square, and Fs is 4. Okay, so with this given data we will solve this problem. So at the end, write down design the shaft, and we have to design the shaft. That means we have to find out its diameter. So small d is equal to question mark. So this is the ultimate answer for this problem. Now let us talk about the important part of this numerical. Now in this numerical statement, there is no any mention of tension in tight side and tension in slack side. But remember that whenever the pulley is given with the belt, so there has to be this tension in tight side and tension in slack side. And as I explained earlier, this tension in tight side and tension in slack side will add to the load. Okay, so right now just we have considered the load as a self weight of pulley, and it is given 350 Newton, but it is not sufficient. But actually, as there is a belt, so we have to add the tension in tight side T1 and tension in tight side T2, tension in slack side T2 in this load, and thus the total load is equal to self weight of pulley, that is W, plus tension in tight side plus tension in slack side. So what we have to do, we have to find out this T1 and T2. We have to add into this self weight, which is given 350 Newton, so that we can calculate this total load acting on this shaft. Okay, and this total load acting on this shaft causes the bending moment MB into this system. Okay, so from this load we can calculate MB. Okay, so let us start the solution. So in the solution, we have to first write that as the shaft is subjected to combined bending moment MB and torsional moment MT, and also the material of shaft is steel, we have to use maximum shear stress theory. One point is very clear, that if the shaft is subjected to combined bending moment MB and torsional moment MT, we have to use theories of failure. Either we have to use the maximum principal stress theory or maximum shear stress theory. That depends on the what material of shaft is there. So material of shaft is steel, and we know that if the material of shaft is steel, we have to use maximum shear stress theory. So therefore we have to use maximum shear stress theory, and the maximum shear stress theory gives the value of maximum shear stress, equation of maximum shear stress, and that maximum shear stress is given by equation tau max equal to 16 upon pi d cube under root mb square plus mt square. So this is the equation number 1 that we have to write into this solution. Now the next point is, as we have seen earlier, this tau max value can be determined, then MB can be determined from this load, total load acting on the shaft. MT can be determined from the power, and once we put the value of tau max, MB and MT in this equation, only unknown remains is D, and that can be easily calculated. So first of all, let us find out the value of maximum principal stress. Sorry, the value of maximum shear stress. So the value of maximum shear stress tau max can be calculated using equation tau max is equal to SSY upon Fs. This is the regular formula to calculate the shear stress. Same formula we can use to find out the maximum shear stress which is required in this equation. So SSY, we know it is 0.5 SYT upon Fs. Value of SYT is 380. So let us put the value of SYT from this given data, and Fs is 4. So let us put the value of Fs 4, and now calculate this value of maximum shear stress which is required in equation number 1. So if you calculate this, you will get the answer as 47.5 megapascal or Newton per mm square. Okay, so this is the first value that is required to be put into this equation number 1. Now let us calculate the MT, that is torque or torsional moment. Now let us calculate the torque MT from this power equation. This torque MT is also called as torsional moment. Okay, so which is required in this equation number 1. Now we know power, it is 2.5 kilowatt. So let us put the value of power 2.5. 2 pi into n is 150 rpm into mt, that we have to determine, upon 60 into 10 raised to 6. So let us calculate this value of mt from this equation. So answer of torque mt is 159.154 into 10 raised to 3 Newton mm. Okay. So now first of all we have calculated Tau max, which is required in this equation number 1. From this equation, its answer is 47.5 megapascal. Then we have calculated mt from this power. Now let us calculate the mb, that is bending moment. Now to calculate the bending moment, we need a total load acting on the shaft in case of belt and pulley system. Now in case of belt and pulley system, along with the self weight of pulley, there is another load, that is tension in tight side and tension in slack side. So first of all, in order to find out this total load, we must find out this T1, T2. We have to add into this self weight of pulley, and then we will get the total load, and then we can calculate the bending moment acting on this shaft. So first of all, we have to calculate the T1 and T2. So write the heading here, calculate T1 and T2. So T1 is the tension in the tight side of this belt, and T2 is the tension in the slack side of the belt. And already we have discussed this procedure to find out this T1 and T2. So first of all, we have to use this equation, mt is equal to T1 minus T2 into radius of pulley. Okay, so mt already we have calculated here. It is 159.154 into 10 raised to 3. So let us put the value of this mt here. 159.154 into 10 raised to 3 is equal to T1 minus T2, both are unknown, into radius of pulley. If the diameter of pulley is 180, so this radius of pulley will be 90 mm. Okay, so let us solve this and let us get the value of this T1 minus T2. So if you calculate, you will get the answer 1768.37 for this T1 minus T2. 0.37. So this is the equation number 1. So in this equation, as both T1 and T2 are unknown, we cannot determine. So we have to use the another equation that we have already discussed, that is the ratio of T1 and T2. So T1 by T2 ratio we have to use here. So T1 by T2 ratio can be obtained by equation e raised to mu theta star, where mu is the coefficient of friction and theta star is the angle of lap or angle of contact or angle of wrap in a radian. Already we have calculated this angle of lap in a radian, it is pi a radian. Okay, and this mu, that is coefficient of friction, is 0.33. So let us put the value here. So T1 upon T2 is equal to e raised to mu is 0.33 into theta star, this is angle of lap, is pi radian. This theta star, that is angle of lap, always must be in radian. So let us calculate this ratio T1 and T2. In order to calculate this T1 by T2 ratio, that is e raised to 0.33 into pi, we have to use the calculator. So press shift and this ln, shift and ln button, you will get here small e into bracket 0.33 into shift pi. So you will get the answer as 2.81. So here you have got the ratio of T1 by T2 as 2.81. So from this ratio you can calculate T1 in terms of T2. So T1 is equal to 2.81 T2. Okay, so put this value of T1 in this equation number 1. So let us write here, put in equation 1. So therefore T1 is 2.81 T2. So here we have to put the value of T1, 2.81 T2 minus this T2 as it is equal to 1768.37. So let us calculate this T2 from this equation. So if you calculate this, you will get the answer of T2 as 971.64. and now unit, as it is tension in tight side, tension in slack side, its unit must be Newton. So this tension in slack side is 971.64 Newton. Let's put the value of T2 here. So you will get the value of T1. So T1 is 2.81 into T2 is 971.64. So we will multiply this by 2.81. You will get the answer of T1 as 2730.33 Newton. So this is the tension in tight side. And now we have to add this T1 and T2 here to get the total load. Now let us calculate the total load acting on this shaft. So total load is given by W is plus T1 plus T2. So W is the self weight of pulley, and the self weight of pulley is given 350 Newton. So 350 Newton is the W. T1 is 2730.33 plus T2 is 971.64. So let us calculate this total load acting on the shaft. So the total load you will get as 4051.97 Newton. Okay, so this is the total load acting on this shaft by considering self weight of pulley plus tension in tight side plus tension in slack side. Now we have to calculate this reaction RA and RB at the bearing A and B. So as there is a symmetricity in this system, so we can write RA is equal to RB is equal to this total load upon 2, and this total load upon 2. So total load is 4051.97 upon 2, and therefore RA is equal to RB is equal to 2025.98 Newton. Okay, so this is the reaction RA and RB. Remember that if there would not be any symmetry, then we have to go for calculating the bending moment at A, B and at this point C. Okay, by calculating the correct value of RA and RB by taking the summation of bending moment at A equal to 0, and by taking the vertical summation of forces, we would have required to calculate this RA and RB. But as there is in this system there is symmetricity, so RA and RB are equal to half of this total load. Now let us calculate the maximum bending moment. So MB is maximum bending moment, and this maximum bending moment would occur at point C, okay, in Newton mm. So it is at point C. So let us take the bending moment about this point C. So this can be taken as RA into this 500 or RB into this distance 500. So RA into 500. So value of RA is 2025.98 into 500. So by multiplying by 500 you will get the value of this maximum bending moment at point C. So its answer is 1.012 into 10 raised to 6 Newton mm. Okay, so this is the maximum bending moment in this shaft. Now we have to use this value, we have to put this value here in this equation number 1 along with the value of MT and tau max, which is calculated in the point number 1 and 2 respectively, and then we can calculate D. So next line we have to write as, put tau max, MT and MB in equation number 1. So I have replaced the value of tau max as 47.5 in equation number 1, value of MB 1.012 into 10 raised to 6 bracket square, plus MT is 159.15 into 10 raised to 3 and its square. Okay, so if you solve this you will get the answer of D. So after solving this equation you will get the answer of diameter of shaft as 47.89 mm. So this is the final answer for this problem, that is diameter of shaft is 47.89. In this problem the important point is pulley along with the belt was given, so we have to consider the total load as self weight of pulley plus tension in tight side plus tension in slack side, and the procedure to find out this tension in slack side, that is T1 and T2, it is important in this problem. And as the material of this shaft was steel, so we have used the maximum shear stress theory and we have determined this diameter of shaft.